Welcome everybody, welcome to AAAI and welcome to Google. Thank you all for coming. My name is Peter Norvig, I'm Director of Research at Google, and I'm going to start off by giving a little introduction to sort of state-of-the-art of AI at Google and maybe a little bit in the world at large. Then we're going to have 5 very short talks on specific technologies from these fine researchers in the front row, and then we're going to get back to the important stuff of talking and drinking. So let's just get started right away. Let's see. Our leaders have been supportive of AI from the beginning. Sergey said in the future search engines should be as useful as HAL in the movie 2001: Space Odyssey, but hopefully they won't kill people. That's something we've been striving for ever since. Larry is the serious rather than funny one, and he said the ultimate search engine will understand everything in the world. So that's our small goal. We can decompose that down into other goals, but first let's talk about what's at stake. And so this is a summary that I've made of a talk by Hal Varian, our chief economist, where he talked about the value of Google to the world's economy. And you can break it down to, there's a value to advertisers. We take in about $30 billion a year, and we've computed that the advertisers get about 7 times that value. There's the values to the searchers, which is really hard to figure out. So sometimes it's really important. You do that search, that you figure out what symptoms you have, and you save your life. And sometimes it's cute kitten pictures. And what's the value of that? But it's some number of billions with large error bars. And then there's the value to websites who use our ads and get some money and some value through that, and get traffic to us for free. And so the bottom line is that the activity that's mediated by Google, and we don't want to claim all of this because we're taking credit here for when we connect you to a website and you get some value from that. We're counting that in this calculation, and of course that's not all us. A lot of that is because the website is out there, but it's somewhere around 1%, and if you were generous, to maybe 2% of the GDP of the world. So it's a big responsibility, and if we can do a little bit better in improving that, it has a big impact on the world. And a lot of what we do to make this improvement is done through AI technology. So that's what's at stake. Now, is now a particularly advantageous time to be addressing AI? And I get asked this a lot, and you know, there are people out there that want to make predictions as to the exact decade in which we have intelligent machines that are going to take over the world. And so I try to figure out, is that going to happen now? And are there any signs that now, or the next 10, 20, 30 years, or whatever, is the right time? And so the research I did is I went onto Google Scholar, and I restricted to computer science, and I searched for the term artificial intelligence and for the term unlike previous. And then I looked at the following phrases, and I wanted to see, over time, what's the new technology that's unlike previous technology that means that right now is the time where, you know, in the old days we didn't know what we were doing, but now we've got the answer. And this is what I've come up with for various publication dates. And I got to say that it's not leading me to any conclusions. I can't say that, oh, you know, back in the 90s we didn't know what we were doing, but now we've got the answer. It just doesn't look that way. And you see, learning from example shows up sort of every decade or so. Unlike previous systems, we've now learned from examples. But I guess we didn't learn enough from examples because we keep repeating that in our publications. So my conclusion is we're making steady progress, but I can't predict when the AI takeover is going to occur from this data. Okay. And what about at Google? And I don't know if you can read that, but this is a random blackboard, and Joel Sapolsky reported that he was talking to a new Googler who said, yeah, the difference is that unlike our former employer, Google uses Bayesian filtering the way they use the if statement. And this is a random blackboard with a formula here, and up on the right it says, all your bays belong to us. And you know, you don't have to look hard. I didn't have to search all over the campus to find a blackboard that was covered with these kinds of symbols. They're everywhere. So that part I think is true. And AI technology, at least to the extent of understanding probability theory and understanding how to maximize and understanding what Bayes' rule is everywhere throughout the company. And, a while ago, we introduced a new internal code search mechanism, right? So everybody's got grep over their code base, but we're Google, so we do things on steroids. And one of our engineers came up with a cool new tool to search over our code base, and I searched for the term naive Bayes, and I forget the number of hits, but it was somewhere up in the 100 or so. Scattered throughout the code. And it was fun looking at the comments because you'd see things like, well, I'm throwing in this naive Bayes now, but I'm going to come back and fix that up with something better later. The comment would be from 2006. I think what that says is that when you have enough data, sometimes you don't have to be too clever about coming up with the best algorithm. But it is awareness that there is this capability to learn from data, and there's this capability to at least think about other algorithms spread throughout the company. What is it that makes Google unique, and or that makes us have this capability to think about these problems? And I'm going to touch on three things. So the first is we got a lot of data. Here's an example of some of the data we published. The 10-gram corpus is available through the Linguistic Data Consortium, so we went through 1 trillion words of English and published all the statistics on it. So you can use it as well. And we do complicated things like empirically based Bayesian maximum likelihood discriminative optimization models. And if you don't know what that means, you can fall back on everything I needed to know I learned at Sesame Street. And basically, while we're doing this counting. Right? So we observe a lot of data, we count it, and yeah, you have to have some model to do smoothing when the counts get to 0. But basically, we're just counting stuff and looking it up. Okay, so that was note number 1. It is data in Sesame Street. Number 2 is working at scale. And I wanted to define the term internet scale, and my colleague Luis Barroso has a way of talking about this, which he says that data center scale is when you get a bill for $100,000 to buy a petabyte of storage, and you say, phew, well, man, that's a big investment. But then Google is operating at the warehouse scale, and there you see our warehouse in Dales, Oregon, filled with computers. And warehouse scale means that you get a page in the middle of the night that says, warning, emergency, there's only a petabyte of free space left. So that's what Luis said in his presentation. I talked to some of the SRE engineers, and they said, we never run down to only a petabyte left. That could never happen. Then the third opportunity is the opportunity to do control. And here we see Norbert Wiener at his desk at MIT. And I think that this is a difference that really distinguishes. That it's not just that there's data out there that we're observing, is that we get to interact with the world, and we get to do experiments and say, if we take this intervention, how is that going to change things? And so we can do things like experimentation, and these are slides stolen from Ronnie Kahavi, who talks about this ability to do experimentation to decide what's working. And his point is that no matter how clever you think you are, you're usually wrong, and you should do an experiment instead. So we can test that. Here's 2 dialog boxes for a find a house website, and the idea is which one's going to get more clicks. So raise your right hand if you think A is going to get more clicks than the left hand if you think B's, and don't raise your hand if you think they're about the same or if you're shy. Any answers? Okay. And the answer is A was 8.5% better. I'm not sure if that counts as about the same or not. Next one, here's 2 sign-up boxes for buying Office online. Right hand if you think A is better, left for B. People aren't sure. Okay. And it turns out A was 60%. So big difference. And That's the way it goes. So the point is that you can't trust your intuition. So you got to go out and do those experiments. And the point is that it's easy to do those experiments, that they're only a click away. And we can set these up and we can gather real data. And we can change the world that way. What else can you do with this data to interact with the world? Well, we have a big effort in data analytics and sort of visualization of this data, how you present all this information in a way that your customers who maybe are not experts in AI or statistics can make sense of. There's efforts in communication. I enjoyed Dave Ferrucci's talk, so I threw him up there in the upper left working on Watson. We have Aardvark, a question answering company. We deal with filtering emails and spam and so on, and handling information overload. And then all these efforts far afield. So speech recognition that you'll hear about, how to build these mobile interfaces, how to understand how to interact with a mobile interface, the self-driving cars, the route finding mechanism. So the first thing I learned in my first AI class was the AI search algorithm, the A-star search algorithm. We have to do that kind of thing, but we have to do it much faster than was ever done before, and we do that by figuring out how to pre-cache and so on. So lots of applications throughout. Another application, the one that I'm currently thinking about a lot, is in terms of education. And then I also think of it in terms of motivation. Now Google has always been an information company. We think about how do we deliver information to the users. But I think motivation is also important. How do you get users excited about wanting to learn? And the education market is $120 billion in the US. E-learning is a $50 billion market, and there's been many approaches. MIT, the campus, has 10,000 students. But MIT, the Open Courseware Initiative, has had 70 million students view their courseware. Khan Academy has 35,000 students a day. Sebastian Thrun and I have put up a course at Stanford, and we're at just about 50,000 students now signed up for that class. So there's a lot of different experiments, and nobody knows yet what works and what doesn't. So there's opportunity for AI, both in terms of the data analytics and in terms of the understanding of human-computer interaction to do education better. Here's just some examples of the Khan Academy, of our course, the MIT Open Courseware. The Amazon Kindle has a thing where you can highlight passages, which is useful to you as a Kindle user for yourself, and you can also elect to share those passages, and then that's useful to everybody because they can see what does the rest of the world think is important. And so the most highlighted passage of all time is the truth universally acknowledged that a single man in possession in one of a wife. So Jane Austen, of course, she gets a big advantage that her book is out of copyright and therefore free. So it's a lot easier to highlight something that's free. And also because she had a good opening line, so you only had to get to the first page. Okay, so that's all the examples I wanted to go through, and now we get to the morals. Albert Einstein says we should make everything as simple as possible, but not simpler. I think that's a good moral, and we see time and time again how we have opportunities to do complicated algorithms, but we do better by just gathering the right data and applying the simplest possible thing you can to it. George Box, a statistician, said all models are wrong, but some are useful. And so we don't worry too much about the science of choosing something that's exactly right. Think of it more as an engineering effort, and if it works, then go with that. And finally, Blanche in Streetcar says, I've always depended on the kindness of strangers, so we can't do it by ourselves. And we rely on data that's out there that's being entered by other people. So authors are writing pages, webmasters are making links, tweeters are tweeting, and we gather up all that information so that we don't have to do it ourselves. Okay.